Welcome to the kitchen. We're going to go ahead and work on our wasted space experiment. This is really cool. I think you're going to enjoy it. I'm going to start off with using the data sheet that the teacher's giving you, and this coincides with the presentation we just did. So I'm going to walk you through the entire thing so you have a better understanding of the differences involved in packaging. So the first thing I'm starting off with is a box of crackers. The crackers weigh 255 grams. I'm going to find out how much this weighs in general, because the first thing it says is to find the store pack mass. So this is the store packaging. Putting this on the scale, and it is 314.7. So I'm filling that in on my sheet, and I will show this to you as we are getting near completion. So then the actual pack inside, I'm going to take this out of the box. And it's packaged. So now once I take that out, now I'm going to lay this back on the scale and find out what we've got. Let's see if we can get it balanced. Okay, we have 267.5 grams. Now keep in mind there's a little bit of weight associated with the bag, so don't worry about that. We're going to keep this real simple for right now. So I'm going to go back and I need to do some more calculations. So I have to find out the volume of the box, and to do this I need three measurements. I need length, width, and height. And if you're not sure which is which, it's really not going to matter, because the law of multiplication says that I can multiply any direction and it's going to come out to be the same answer. So I'm going to get my ruler and I'm going to use, I'm going to measure from left to right. This is the easy way to remember. I can do left to right, bottom to top, and then front to back, and that way I know I have three different numbers. So here we go. This is my left to right, and that says that it is 12.6 centimeters. So I just plug that number in. Now I'm going to go top to bottom. My top to bottom number is 19.5 centimeters. And then my front to back is 7 centimeters. So in a few seconds I'll plug all these in, and right now then I have to calculate the volume. So to do that I'm going to multiply those three numbers together to get my volume. And we will come back to that shortly. But let's move on to the next part of how we're going to do this. So I'm going to move the crackers out of the way, and now I'm going to go ahead and move to my nuts. I have peanuts that I'm using. In the United States, we can't use peanuts in classrooms, so I'm going to take the pleasure of doing peanuts since I don't need to be worried about this. So the first thing I have to do is I need to find out how much these peanuts weigh, but I have to put them on a plastic tray, so I have a little something I have to worry about because I can't just throw them on the scale. So what I'm going to do is find out the weight of this little tray is 16.2 grams. So I'm going to have to take that number back out. If you have a fancy scale, it's called tare, T-A-R-E. So I'm just going to add it for right now, just to keep things simple. I'm going to put the peanuts on here. I'm doing 10 peanuts. So I've got my 10 peanuts on my scale. And my number now is, my total mass is 45.7 minus 16.2 is going to equal 29.5 is my total mass of just the peanuts. Okay, so now the next thing I have to do is I have to break these apart. I got to find out, I got to worry about just the peanuts. So I'm going to do this again. I'm going to just pop these out really quick. Peanuts are great for that. And I see little bits and pieces. I'll put them back on the tray since I already know the weight of the tray. And I'm just, I want to find out how much these peanuts, how much are we paying for this packaging to send it to space? So we have to be concerned about that. It does cost a lot of money, $10,000. Keep that in mind, per pound, which equates out to what, 454 grams or something like that. So here we go. I'm getting all this edible, the parts that are edible I'm putting on this tray, and then the shell, I'm not worried about the shell, but I'm going to surprise you with what you're going to see in just a second. I'm almost done cracking these open. Here we go, and we don't need some of that skin. Peanuts, by the way, if you're not familiar, I don't think you have any peanut farms in China. Peanuts grow underground. They're really cool. They are a root crop, and they grow underground, and they grow in very dusty places. One of our largest producing states in the United States that does peanuts is the state of Georgia, which is south of where I live, about 5 hours south. 5 hours by car. About an hour and a half, 2 hours by plane. Okay, so you see, look at all this mess I'm making. This is just crazy. So I'm down to my last couple of peanuts. Don't want to lose any pieces here. My patient camera person is being very patient because she knows I'm not real quick at doing this whole peanut thing. And this is the last peanut we have to worry about. Okay, so there we go. This is the edible, make sure I didn't miss anything. Don't want to leave any good peanuts behind. This is the edible portion of the peanut. This is the part that we can eat. So here we go again. I already know that the weight of this tray was 16.2 grams. Let me turn this scale back on. And now let's just find out the edible portion of the peanuts. Oh my goodness. The edible portion, and I'm going to have to double check my math, is 35, oh actually no, it's 35.7. So if I subtract the weight of the tray, just doing some quick math here for you guys, the edible portion is 19.5 grams, which is 10 grams less, including when I had the shells on there. So we'll go back and do the math a little bit later on. So I'll show you that calculation. I'm going to move this off to the side for now, and I'll come back and we'll fix that. And I just saw escaped peanut. So we're going to not go back and recalculate for now. Actually, we need to. Let's just fix that real quick. Found an escaped peanut. Put that back on the scale so we have accurate data. 36.3 minus 16.2. 20.1 grams of actual edible peanut. So like I said, we'll come back. Now, we're not done yet because we now need to know how much the shells were. So I'm going to move these out of the way for now, put them in a container. And I need to know how much of these shells. Again, we know that our tray is 16.2. Can't quite see that number. Let me move the peanuts just a little bit. There we go. 25.5 with the tray. And then I'll take away the amount for the tray itself. 9.3 grams of shell that you're not going to eat. So that would be weight, and if we put that using the formula of NASA, that's a lot of money just for the shells. And they can't eat them anyway, so why send them? Okay, so now let's move on to our next one. We're going to take care of this piece of fruit. Apple. Astronauts love apples. Got a lot of vitamins in them. So I want to find out how much is the weight of the entire apple. So the whole apple itself is 138.6 grams. And that is just the whole apple. So now I'm going to quickly peel this apple. Just give me 1 second. Get this peel off. A lot of people don't like the peel. I like the peel. But we'll take the skin off this apple, and then we're going to take the core out because we don't need the core. So this is just to give you an idea, even with natural foods, we still have, if we had to ship this to the space station or out to space, we have to be worried about the cost involved. So here we go. I'm down to the last little bit here, and then I'm going to remove the core so you can see that, losing my peels here. Okay, and now my handy dandy corer, I'm going to put that through because I'm not going to eat the core. So I'm just going to remove the core like that. I'm not going to eat it. and the core comes out like a cylinder. Kind of cool. And now let's find out what the apple is, just the edible portion. So I'm going to put this directly on the scale. I'll wipe it off later on. 108.0 grams. That's significant if you think about it. So I will end up doing the math. I'm going to use a calculator to make sure that my calculations are accurate. And then I'll go ahead and send the teacher the actual answers that I came up with, so then you have a guide for when you do yours if you do this in class. Just another way to find out what we're wasting in terms of weight if we're sending it to space. I hope you enjoyed this. I'll be back with you shortly.